In this next video, we will look at correlation coefficient between two data sets. This is our next parameter we are going to look at in our series of statistical analysis videos. So correlation coefficient is usually indicated by the small r variable. Sometimes we use the Greek letter rho to indicate the correlation coefficient. What does it mean? Well, it is simply the measure of the strength and direction of the statistical relationship between two variables. So if two variables x and y are related to each other very strongly, then and in the same direction, then it will give us a value that is close to +1. If the same two variables x and y are related very strongly, however in the negative direction, meaning that if one is increasing, the other one is consistently decreasing, then it will give us a value close to -1. And if the two variables are unrelated, which means that the relationship between them is very weak, then it will be a value which is very close to 0. So that's how we are going to use the correlation coefficient to indicate relationship between two variables. How do you calculate R? Well, we are going to use this formula to calculate the correlation coefficient. In this formula, you already know a lot of the parameters already. So for example, xi and yi are the elements in x and elements in y. X and y are the two variables we are using for this formula. X has elements x1, x2, x3 and so on. Y has elements y1, y2, y3 and so on. Both the data sets x and y have the same number of values, capital N, which we are using in this formula as well. X bar and y bar indicate the mean of x and mean of y. These are the arithmetic means or the averages of x and y. And then sigma x and sigma y, those are indicating the standard deviation of x and standard deviation of y respectively. So we have seen earlier videos in which we go over how to calculate the mean and standard deviation of a data set. You're going to do that and then plug it into this formula and run this summation over all the elements of x and y and compute the correlation coefficient R, which is going to be a value between -1 and 1. Over here, we have 6 different plots of different correlation coefficients. And let us see if we can figure out whether these values of R make sense based on the points. So all these 6 plots have x information on the x-axis and then the y information on the y-axis. And if I look at plot A here, as I increase x, y consistently goes down and it is very linear, so it suggests that x and y have a negative correlation, negative dependence. And because it's a very close line, the correlation coefficient in this case is -1. Now if those data points kind of spread out a little bit, I'm going to get a value which is different from -1. However, it is still going to give me negative correlation, because as I increase x, in general, y keeps going down. In this third plot, there's no such relationship, so the value comes out to be close to 0. So as I increase x, y sometimes increases, sometimes decreases, so it's a value which I cannot make sense of, which is why R is 0. D is positive correlation, so R is 1. And it is very linear, so as you increase x, y also increases in a very, very linear fashion, so it results in a correlation coefficient of +1. Plot E is positive correlation, however the points are a little bit spread out, so in general they are increasing, but not very linearly. So the strength is not 100%, but the direction is positive. So 0.86 positive for correlation coefficient for E. Now for this last case, as I increase x, y starts to increase and then decrease exactly in the same fashion, giving me complete independence. So R0 indicates that x and y are completely uncorrelated. So these are independent variables in this case. Okay. We are going to use Matlab function CORR to find out the correlation coefficient between two data sets in x and y. If we can set up x and y as two vectors containing the data, we can use this function to find out the correlation coefficient between them. Note over here, this function returns a 2 by 2 matrix. And each of these elements is going to correspond to the correlation between x and x itself, x and y, y and x, and y and y. And it is very easy to guess over here that the correlation between x and x is going to be 100%, so it's going to be a 1. And y with itself is going to be very correlated, so this element is also going to be 1. But the off-diagonal elements are going to give us the actual correlation coefficient between x and y. They are both going to be the same, but these are the value we are interested in, x with y or y with x. Now let's see if we can use some Matlab commands to demonstrate this. So over here I have set up x and y as two vectors. These vectors have 3 data points in x, 3 data points in y, and I'm using this function CORR to find out the correlation coefficient between x and y. So when I run this, I get x is 1, 2, 3, y is 2, 3, 4, and as I increase x, I see y linearly increasing, which means that the off-diagonal elements are going to be giving me the correlation between x and y. In this case, it is 1, because this is perfectly linear positive correlation. However, if I changed y a little bit, say for example, if I changed y to 2 and I ran this again, it is going to tell me that x with x is 1, y with y is 1, but x with y is still positive. However, it is not very strong. So the correlation coefficient has gone down from 1 a little bit, but it has not, it's still very correlated. Okay, so I hope you find this video helpful in looking at the dependence or the correlation between two variables.